Paradox handling. When the universe breaks its own rules, there's a place at the very edge of understanding, a boundary where reason begins to falter, where the universe, in all its brilliance, starts to contradict itself, and somehow keeps going. You're not supposed to see it. But when you stare long enough, when your questions dig deep enough, you'll find them. Paradoxes, the silent fractures in logic, alive, stable, functioning, and yet they shouldn't be. We call it quantum mechanics, but really it's the study of the impossible that somehow persists. Particles that are here and not here. Events that influence each other across galaxies instantly. Outcomes that remain undecided until you look. It's as if reality was never meant to make perfect sense, like a simulation running code too advanced for its users to fully grasp, designed not to avoid paradox but to absorb it. Take Schrödinger's cat, a thought experiment that sounds like fiction, but is uncomfortably real. A cat, both alive and dead, inside a box. A superposition, a paradox. Until it's observed, both outcomes exist simultaneously, two contradicting realities suspended in harmony. This isn't metaphor, this is physics, and the universe doesn't crash. It doesn't throw errors. It simply continues. Ask yourself, what kind of system can not only tolerate contradiction, but thrive within it? Our everyday world abides by a clear narrative, cause and effect, logic and law. But on the quantum level, those rules blur, and still, the sun rises, clocks tick, hearts beat. Paradox doesn't break the simulation, it powers it. Think about how we design software, complex games, artificial realities. When they grow too large, too detailed, too intricate to predict every outcome, we don't write rigid rules. We write error tolerance, fail-safes, redundancy, systems that embrace the unexpected. Now imagine a universe as software, a simulation vast enough to house trillions of particles, branching timelines, and conscious observers, all at once. Would it be built on strict logic, or would it need flexibility? Would it need to handle paradox, quantum superposition, entanglement, probability waves? The universe bends but never breaks. It curves around the contradictions, adapting with elegance, like a cosmic operating system that expects the unexpected. Because paradox in this framework isn't a bug, it's a feature, and perhaps a necessary one. In quantum computing, it's paradox that enables power. Qubits exist in multiple states until they don't. Contradiction isn't destructive, it's efficient, it unlocks exponential possibility. So what if the quantum world is just a glimpse of a deeper design? One where logic as we know it is only a user interface? A simplified overlay for something infinitely more complex. Reality, then, may not be governed by absolutes, but by possibility, by systems written in a code base of probability and flexibility. Physicist Hugh Everett once proposed that every possible outcome does happen, splitting the universe into countless versions of itself, each a response to paradox, each a timeline that didn't crash but branched. We live in one, and so do the others. You are the sum of choices, but every choice is also a fork, a contradiction, a data split, and yet your reality remains seamless. No flickers, no freezes. The illusion of continuity perfectly maintained. That's not fragility, that's mastery. A simulation that can render impossibility and still feel real. And if we do live in such a system, then what is consciousness? Free will? Are they not also paradoxes? The ability to choose freely in a universe governed by deterministic physics. The sense of self arising from a brain made of particles that obey none of the rules we associate with logic. These two are contradictions, and the system absorbs them. It has to. To simulate a conscious entity, an observer capable of inquiry, creativity, and rebellion, it must permit contradiction. It must allow uncertainty. Because without that, we are predictables, and predictable systems are not alive. So maybe paradox is not a flaw to be solved. Maybe it's the architecture of aliveness, a design choice made by the unknown creators of this simulation, if they exist, so that emergent intelligence could arise, ask questions, make art, feel love, and wonder what the hell is going on. Every time a quantum particle behaves irrationally, every time a scientific model collapses under too many variables, every time a philosopher loops between free will and determinism, the system doesn't fail. It nods quietly and keeps running. So next time you read a physics paper that ends with "we don't know why," or feel the strange weight of your own existence, don't fear the contradiction. It's the signature of a system far beyond your understanding. And the paradoxes, they're not holes in the fabric. They are the stitching, the proof that this reality isn't fragile. It's elastic, resilient. Simulated or not, it is built to bend without breaking. And in those bends, in those impossible curves, we glimpse the design. Not by what the universe explains, but by what it survives.